Welcome to This Explainer. Think about mathematics for just a second. For most of us, it's the unshakable bedrock of reality, right? I mean, it's the language of physics, it's the engine of the entire global economy, and it's literally the blueprint for the architecture of our cities. We treat mathematical certainty as the closest thing humans have to absolute, undeniable truth. But today, we're exploring a truly mind-bending critique of that exact foundation. We're going to examine a source text that impartially, yet aggressively challenges the absolute core of mathematical reality. It's a concept that forces us to look at the systems governing our entire modern world through a radically different lens. Let's get started. Okay, let's dive into this by thinking about something we all take completely for granted. We use numbers to count, to measure, to trade. We use them to engineer the complex suspension bridges we drive across and to code the intricate software we rely on every single minute of the day. But I really want you to pause and deeply consider a deceptively simple question. What exactly is a number? If you were pressed to give a rigorous, ground-up, undeniable definition of a number itself, not just an example, like pointing to the number 5, but the foundational definition of the concept, what would it actually be?
Well, our source text introduces a genuinely shocking premise right out of the gate, claiming it is merely hand-waving what a number is. The big argument here is that the global mathematical establishment has essentially bypassed a formal, airtight definition of its most basic unit. The text asserts that, for centuries, the concept of a number has been treated as this simple, intuitive given. It's kind of like mathematics started somewhere in the middle, without ever truly defining the very blocks it's building with. Imagine trying to construct a towering skyscraper, pouring millions of hours into the intricate blueprints for the penthouse, but you never actually stop to verify if the concrete you're using for the foundation even exists. That is exactly the critique being leveled here.
Now, what's really interesting about this slide is how the author formalizes this massive problem into a concept called the ontological void. According to this source, because the fundamental unit, the number, lacks a proper definition, the entire discipline runs into a staggering logical debt. If you haven't defined what a single solitary number actually is, the text argues, you absolutely cannot have a rigorous foundation for massive complex concepts like infinity or mathematical continuity. If the underlying structural integrity of a single mathematical brick is totally undefined, then those grand overarching ideas simply become secondary abstractions. They are, quite literally, built on air.
And this brings us directly to the traditional academic battlegrounds of higher mathematics, finitism versus infinitism. For generations, theorists have typically been forced to choose a side in this agonizing debate. You either believe that mathematical objects are strictly limited to the finite, things that can eventually be counted to an end, or you accept the sprawling existence and properties of the infinite. It's always presented as the ultimate either-or scenario, the great dividing line in how we understand the universe of numbers. But our source text completely rejects both of those labels, and the reasoning is absolutely fascinating. The author states, with clear disdain for the establishment's methods, that mathematicians are engaged in a categorization of ghosts. The core argument here is that forcing a choice between the finite and the infinite is a complete logical absurdity if the underlying object has no formal identity to begin with. You simply cannot categorize the scale or the limit of numbers if you haven't definitively identified what a number is in the first place. Going back to our analogy, it's exactly like bitterly arguing over the exact height of a building when you haven't even proven the bricks exist. It's a highly sophisticated debate about phantoms. So the crucial point is, how does the author propose we fix this? Well, to restore actual rigor to mathematics and pull it out of this theoretical void, they argue we must establish functional criteria for what constitutes a proper number. The text lays out 3 uncompromising axioms of validity: identifiability, comparability, and arithmetic operability. These aren't just polite suggestions, they're presented as an absolute purity test. Let's break these down one by one to see exactly what the author is demanding. First up, we have identifiability. The text argues that any valid number must have the capacity to be uniquely and definitively distinguished from all other entities. It absolutely cannot be ambiguous. Think of it like this. If I hand you an apple, you can easily identify where the skin of the apple ends and the air around it begins, right? It has a definitive boundary. The text argues that numbers must have this exact same definitive boundary. If you cannot point to a numerical concept and definitively say where its identity begins and ends in relation to everything else, then according to this strict criteria, it completely fails the first test of being a true mathematical number. Next, we have comparability. Once a number is clearly identified, you've got to be able to establish its definitive, non-arbitrary relative value. This basically means knowing absolutely, without a shadow of a doubt, where a number sits on a scale relative to everything else. It must hold a permanent, unshakable position in a hierarchy. If its relative value is a moving target, or if it relies on an endless sequence that never actually resolves into a final value, well, it fails the test of comparability. It's not just about knowing what the number is, it's about knowing exactly where it permanently lives. And finally, we reach operability. This means the absolute necessity of the entity being subject to formal calculation and manipulation. You have to be able to do airtight, verifiable arithmetic with it. The devastating realization here is that when you apply all three of these rules, identifiability, comparability, and operability, with genuine rigor, the author argues that the amount of numbers that can actually be proven to exist becomes strikingly limited. Applying these axioms acts like a giant scythe, cutting down vast swaths of what we currently consider to be valid mathematics. And this brilliantly illustrates the real-world consequence of those strict axioms. Take E and pi. These are absolute giants of the mathematical world. I mean, they're foundational to calculus, physics, geometry, and engineering. But the author makes a highly provocative claim here. Under the unforgiving axioms they just covered, the text argues that E and pi are not actually numbers at all. Instead, the author calls them phantoms of approximation. Because a concept like pi is infinite and transcendental, meaning its decimal representation goes on forever without ever settling into a repeating pattern, you can never lock down its exact final identity. You can never perfectly compare it in a finite calculation because you can literally never reach the end of it. Therefore, the source argues, these are merely symbols used to mask the fact that the strict criteria for a number cannot be met. If this critique holds true, it turns a massive amount of higher mathematics into a mere manipulation of symbols representing a reality we can never actually reach. This naturally leads us to a really massive question, one that bridges the gap between this highly theoretical philosophy and our real everyday world. If the foundation is truly missing, why does the system survive? If mathematics is essentially operating with a massive void at its core, why do our airplanes still fly? Why do our smartphones still work? Why hasn't the entire structure of modern science, engineering, and finance completely collapsed into chaos? The source text answers this with a fascinating concept defined as a convenient coincidence. Now, to be absolutely clear, the author does not see some deliberate, smoky room financial conspiracy at play here. Rather, it's described as a parasitic necessity. The absence of absolute mathematical certainty created a vacuum, and over centuries, human beings have successfully, albeit unintentionally, monetized that vacuum. We found a system that practically works on the surface, even if it's theoretically bankrupt underneath. The system survives and furiously maintains itself simply because it supports the economic survival of millions of people. Isn't it crazy how human society works? The text claims we are essentially operating under a veil of unearned certainty. The argument is that this massive intellectual insolvency remains uncorrected, not because brilliant mathematicians are incapable of addressing it, but because the real-world economic consequences of admitting the truth would be just too catastrophic to bear. Imagine if the global financial markets suddenly had to concede that the underlying math calculating trillions of dollars in derivatives had no definitive logical base. Banks would fail. Algorithmic trading would completely shatter. The sheer practical utility of financial survival completely masks the vacancy of the logic. And the author does not back down from this stance. They issue a stark, unyielding challenge to the entire mathematical establishment. Show me an assumed proper existing definition, and I will show you the flaw in it. The author places the burden of proof directly and heavily on the centuries-old institution of mathematics itself. It's a bold demand to finally produce the logical foundational ground, or publicly admit that the discipline is building its towering world-defining structures on thin air. Which leaves us with this final provocative thought to conclude our explainer. Is mathematics building on truths, or is it building on air? Whether you fully agree with the aggressive stance of the source text or not, it definitely forces us to deeply question the reality of the systems we trust blindly every single day. It reminds us that sometimes the most complex and powerful systems in the world might just be resting on fundamental questions we simply forgot to ask. I hope this deep dive sparked your curiosity to look a little closer at the invisible foundations of our world. Keep questioning and keep learning.